Okay, so for my problem, we have consider w is equal to z minus 1 over z plus I, where z is equal to x plus iy, the general form of a complex number in Cartesian, and that I is equal to radical negative 1. So for letter A, part 1, if z is equal to I, write w in the form of r cis theta, which is also known as the polar form of a complex number. So to tackle this problem, we would first have to replace z with I. That would give us w is equal to I minus 1 over 2I. And we do not want to have an I in the denominator. We want to express this fractional complex number into its simplest Cartesian, x plus iy. To do that, to get rid of the I, we could multiply 1 minus x over 2I times negative I over negative I. And that would give us and if you split the fraction, you would have 1 over 2 plus 1 over 2I. So now we have our w in Cartesian, but we want to express it using polar. And to do that, we have to find two things. Oh, by the way, you get 1 point if you correctly identify the Cartesian form. And the first thing we have to find is the modulus, which basically you just use a Pythagorean theorem. Oh, it can also be expressed as the r. Here our x represents the real value on the argand diagram. Our y is the imaginary part on the argand diagram. In this case, both our x and y are 1/2, as we can see here. So just plug everything in. And now, using some exponent properties to help us further simplify, okay, now we do not want to have a radical on our denominator. So we simply just multiply the radical 2 over radical 2, and that gives us radical 2 over 2. So this is our modulus. Now we're going to move on and try to find the second thing, which is the argument. Just keep those in mind. Okay, the argument, basically on the argand diagram, you have the x here, you have the y here. The x is a real number, y is an imaginary. Let's just try to plug in w. So here. And this angle that you're trying to find will be the argument expressed in theta. There's actually an equation for it, which is here. A common mistake that some students tend to make is that when they're rushing, they get mixed up with the x and y. For example, they might put the x value as the numerator, the y as the denominator. So just make sure you keep an eye on it when you're getting to this part. And now we just have to plug in our values, since we already got it from previously. It's just 1/2 over 1/2, which is 1. And inverse tangent of 1 is just 45 degrees or pi over 4. But in polar form, we always want our values to be in radians. So in this case, we're going to keep pi over 4 as our answer. Okay, now that we have our argument, and oh, by the way, you get another point if you could correctly identify both the argument and the modulus. So plus 1 point here. Okay, now we have to find both the modulus and the argument. Now we just have to plug in everything in the formula for polar form, which can be expressed as z is equal to r cos or r sin beta. In this case, r is the modulus, beta is the argument. And now just plug it in. Oops. There you go. Since the question asks you to put w in cis form, there we have cis. And so, yeah, this is how we solve number 1 for part A. And some skills and concepts that you have to understand is be able to convert Cartesian to polar form, identify the polar formula, be able to know how to use this formula. How do we find the modulus? What's the equation for it? How do we find the argument? What's the equation for it? And avoid common mistakes such as mixing up the x and y values. And so yeah, these are the things that you should be able to do to solve this problem. Oh, just want to clarify that you also get another point for able to find the final answer. That's a total of 3 points for part 1, letter A. Now we're going to be doing part 2. Here we have part 2, and to be able to find w to the 14th power, we're going to have to use the Morse theorem. The formula can be expressed as okay, so this is the formula, and previously we have got the result as radical 2 over 2 cis pi over 4, and now just apply the formula. This part, just use your GDC. If you simplify, you would have 1 over 128. And just notice how 7 pi over 2 can also be expressed as 3 pi plus pi over 2. And understanding this, the unit circle, we have it goes from pi, it goes 0 or 2 pi to pi over 2 pi 3 pi over 2. So this is as if the circle has already gone 1 rotation, 2 pi, plus half of the rotation, pi, that's 3 pi, and then plus pi over 2 again, which we end up being 3 pi over 2. Right? And we can just replace this as 3 pi over 2. Okay, again, understanding unit circle, when the value is at cosine 3 power over 2, it is 0. And then when the value of sine at 3 power over 2 is -1. So yeah, brackets, not make this confusing. So that would give us 0 minus I. And this is your answer. So you get 1 point for identifying and knowing that we have to use the Moivre theorem. Another point for finding the answer. Okay, so common mistake that a student might make is that they might mess up when it comes here. They might fail to understand that 7 power over 2 can just be expressed as 3 pi plus pi over 2, and they don't recognize how it is just like circle rotations. It is the same thing as this 7 over pi is the same thing as 3 pi over 2. That's one mistake they can make. And another mistake is that they might here, when we are finding the values of cosine and sine, sometimes students get confused with different signs. Here we're at third quadrant. In this case, both the sine value and cosine value will be negative. So some students might put positives here, or some students might put just positives here and get mixed up. So yeah, these are common mistakes. And skills that we have to recognize that first we have to know how to use the Moivre theorem, how to apply the formula. And then we have to understand this idea of unit circle rotations, revolutions, how this value can just be expressed differently, and how like 7 pi over 2 is just 3 pi over 2 with an extra rotation, another revolution. Because in this case, if we express it as 7 pi over 2, also we need to understand unit circle values. In this case, it includes 3 pi over 2, and we can just find it there. But if we just have 7 pi over 2, we don't know the value in the unit circle because it is never provided. So we have to do some simplifications here. So yeah, understanding the Moivre theorem, knowing circle revolutions, and knowing the equation, the values of each the number of each value in the circle in the unit circle. So now moving on to part B, show that in general W is equal to parentheses x squared minus x plus y squared plus y, close parentheses, plus I, parentheses, y minus x plus 1, close parentheses, over x squared plus parentheses y plus 2, parentheses 2 second squared. This is a problem of proving, so that we basically have to try to get the equation of W looking something like this. And so recalling back, W is equal to z minus 1 over z plus I. This is given. And now we just have to substitute z is equal to x plus iy back into this equation, which will give us now just like get rid of the parentheses, we would have and just putting everything together, having the y in the end and having the real values in the front. Just a bit of rearranging the values. Okay. Now what I want to do is just factor out the common terms and group everything together. So we're gonna group the real values with the real values and imaginary values with the imaginary values. So now we have that. So we want to get rid of the, again, we want to simplify this complicated complex number. And what we could do is we could multiply with the conjugate of the denominator, so we could just simplify the denominator first. That's what we always want to do, multiply the conjugate of the denominator. So we would have this. And now just simplify, you simplify everything, and you do FOIL, you would have okay. Now we just gotta first simplify. It seems like our denominator is equivalent to the one we have here. Now we just gotta simplify our numerator. So just again FOIL everything. Just draw a line so we don't get confused. Let's just ignore denominator for now. So we just gotta simplify numerator. And now what we want to do is, again, we want to group like terms. So putting the I values together and the real values together on one side. And we're going to factor out the I. Factor out the I. Would end up with this. And notice how we canceled out this term and this term here. That's why these two are gone. And now putting everything back together, we will have the exact values. Okay, so here we go. We have our final answer. And a few things in mind is, first, we have to know the concept of a conjugate. How do we apply a conjugate to help us facilitate in simplifying or finding a solution? We're trying to prove what the equation equals to for a complex number. And then is that we have to understand how to factor out like terms. Like here we have, for example, here we factor out the I to resemble the one that the answer give us, the question give us. And then also grouping like terms, how we have here, for example, we have grouped the x's, the one without the I on one side and the values with I in the other side. Common mistake, this probably has a lot of room for errors when it comes to algebra and simplification, especially when you do FOIL. When students do FOIL, they tend to mess up the signs, or they could tend to, they might not be able, they might miss a variable, and that could lead to big problems later on, since they all depend on each other. Also here, again, FOIL, the signs can be really confusing, especially you have a rather long equation. And so yeah, that's the common mistake that even I made first time doing this problem. Besides that, oh, you only get 1 point. You'd get, this problem has 4 points, so you get 1 point finding the final answer. 1 point for multiplying by the conjugate. And just over the simplification part, you would have 2 points. From going from here to here, and eventually find the solution. So that's in total of 4 points.